Hey guys, welcome back. So today we're going to be talking a little bit more about the pH scale and how it works. So a quick reminder, the pH scale shows us how acidic or basic a solution is. Neutral is 7. Everything below 7 is acidic. Everything above 7 is basic. So if we look at a pH scale like this, something like pure water would have a pH of 7. But vinegar has a pH of 3. Would that make vinegar an acid or a base? That's right, it would make vinegar an acid. And here we've got ammonia. Ammonia has a pH of 12. Would that make ammonia an acid or a base? Good, that would make ammonia a base. According to this chart, what substance is our strongest acid on this chart? That would be hydrochloric acid. And what is the strongest base on this chart? That would be up here at pH 14, sodium hydroxide. So the pH scale goes from acidic to basic, with 7 being neutral. But the pH scale is a little weird. It's logarithmic. Okay? It is actually the measurement of hydrogen ion concentration. You may see this shown like this sometimes. Oftentimes when we have an ion in brackets, it's denoting its concentration. So an increase of 1 pH unit is a tenfold decrease in our hydrogen ion concentration or acidicness. An increase of 2 pH units would be a 100-fold decrease in hydrogen ion concentration. And that's because every step on the pH scale is like moving 10 steps. So something that is, something that's, say, a pH of 5, well, that would be 10 times more acidic than a pH of 6, and 100 times more acidic than a pH of 7. Something that's a pH of 10 would be 10 times more basic than a pH of 9, or 10 times less acidic than a pH of 9. Because you're either a base, or you're either basic or you're acidic, or your basicness and acidicness are balanced, in which case you're a 7. So here's a quick example. If we were to do a pH change from 7 to 8, are we becoming more acidic or more basic? Well, that's right, we're becoming more basic. And our hydrogen ion concentration would be 1/10 of the original, which means we are becoming 10 times more basic. If we were to change in pH from 7 to 9, how many times more basic is that? Well, that's 100 times more basic, because each step is a factor of 10. Here, if we're to look at our pHs of some common substances, here we've got our pH, okay, our measure of basicness or acidicness. Here is our hydrogen ion concentration. That's what acids release. Here is our hydroxide ion concentration. That's what bases release. And if you notice, if we're at a pH of 7, those two amounts are the same because the hydrogen and the hydroxide ions are balanced. But if we start to move down into the acidic range, we see our hydrogen ion concentration is much higher and our hydroxide ion concentration is much lower. I want to point something out here. It's kind of a cheat. If you look here at our hydrogen ion concentration exponent, and here at our hydroxide ion concentration exponent, if you add -4 to -10, what do you get? You get -14. If we add -3 to -11, what do we get? Negative 14. What if we add negative 9 to negative 5? What do we get? You got it, negative 14. And what is the highest value on the pH scale? Just happens to be 14. So let's run through a few practice problems. If we have a decrease of 1 pH unit, that would be a 10 times increase in hydrogen ion concentration. That means we are becoming 10 times more acidic. If we decrease 2 pH units, moving down 2 units, then that would be a 100 times increase in our hydrogen ion concentration, which means in that case we are 100 times more acidic. So, if we change in pH from 7 to 6, our hydrogen ion concentration is 10 times that of the original, which means we are 10 times more acidic. If we move from 7 to 5, we are, actually this is a typo, it was 100 times that of the original because we're moving 2 steps, so that would be 100 times more acidic. So how do we determine the pH from the hydrogen or hydronium ion concentrations? Well, that's easy. Remember, the pH is the negative of the common logarithm of the hydrogen ion concentration. So pH is the negative log of the hydrogen ion concentration. That's how we would write it. So let's look at an example together. If we have a solution that has a hydrogen ion concentration of 1 times 10 to the negative 10, what would be the pH? Well, this is very easy. We look at this, we could do a whole bunch of math. We could say the pH is a negative log of 1 times 10 to the negative 10, or we can just look at the negative exponent, and we drop the negative sign to find the pH. So here's our negative exponent, negative 10. That means we are a pH of 10. If this were a concentration of 10 to the negative 4, then our pH would be 4. And if it was 10 to the negative 14, our pH would be 14. It's that easy. You just look at this exponent, drop the negative, and that's your pH. So here's an example we'll do together. What is the pH of a solution containing 1 times 10 to the negative 3 moles per liter of hydrogen ions? What is the concentration of the hydroxide ions? The sum of the exponents must equal negative 14. So here's how we would work that out. If we have 1 times 10 to the negative 3 moles per liter of hydrogen ions, that's our concentration. If our exponent here is negative 3, that means that our pH is 3. What would our concentration of the hydroxide ions be? Well, that would be the opposite of the concentration of the hydrogen ions. The hydrogen ions are 1 times 10 to the negative 3. That means our hydroxide ions would be 1 times 10 to the negative 11, because when we take these exponents and we add them together, we want it to equal negative 14. So that would be the hydroxide ion concentration. Let's look at another one. What is the pH of a solution containing 0.00001 moles of hydrogen ions? Is this solution acidic or basic? And what is the concentration of the hydroxide ions? So if we have a pH containing this molarity of hydrogen ions, we need to convert that into scientific notation. So we move our decimal 1, 2, 3, 4, 5 places, be 1.0 times 10 to the negative 5. So that means that our pH would equal what? Our pH would be negative 5. What would the concentration of the hydroxide ions be? Well, if here we're 1 times 10 to the negative 5, and that's our hydrogen ion concentration, that means that our hydroxide ion concentration would be what? Well, it would be 10, it would be 1 times 10 to the negative 9. Alrighty, let's take a look at our next question. Oh, we didn't answer if that was acidic or basic. So if you have a pH of 5, which is what our answer was there, would that be acidic or basic? Well, that would definitely be an acid because it's less than 7. Here's one for you to try. What are the relative ion concentrations in an acidic solution? Well, the correct answer there is that we would have more hydrogen than hydroxide ions, because you always have a little bit of both. But if you're an acid, you would have more hydrogen ions than hydroxide ions, because hydrogen is released by acids when you put them in water. Let's try another practice question. You have a truck carrying concentrated nitric acid. It overturns and spills. The acid drains into a nearby pond. The pH of the pond water was 8 before the spill. After the spill, the pH is 1,000 times more acidic. What is the new pH? And what is the new hydronium concentration? So there's a few things here we're going to break down. So we start with a pH of 8 before the spill. That would be in the basic range. After the spill, the pH is 1,000 times more acidic. So that means we're moving how many steps on the pH scale? So for 1,000 times, that would be 10 times 10 times 10. So we're moving 3 spots on the pH scale. And we're moving 3 spots in the acidic direction. So if we were starting at 8, that means that we are going to be arriving at 5. So our pH will be 5 because we moved 3 spots from 8 down to 5. What would the new hydronium concentration be? Now don't get confused here. Hydronium is another way to refer to that hydrogen ion, and we're going to talk about that more in a little bit. But that's really asking what's the new hydrogen ion concentration. Well, if our pH is 5, that means that our hydrogen ion concentration is 1 times 10 to the negative 5 is our hydrogen ion concentration. Thanks. So in our next video, we'll talk about pH indicators.